Hi, this is Ed Legaspi. I'm a senior Java developer, currently an advocate at AWS Serverless. Today I'm gonna show you how an authentication token can be exchanged between Keycloak and Google. This will allow Keycloak lag users to call Google services, which is very useful if you have a product secured by Keycloak and would like to access Google APIs such as email and calendar.
The learning objectives of this video is to introduce Keycloak, introduce Google APIs, and to learn how a token can be exchanged between Keycloak and Google. For the outline of this video, we will introduce and configure Google Console, we will introduce and configure Keycloak, we will create a Spring project for demonstration, and finally, we will test our project.
Let's start with the overall conceptual diagram of what we're trying to do.
The problem that we're trying to address here is how our service can access Google APIs by using the users registered within Keycloak. So what happens here is that we have a client that calls our service. So that service will authenticate the user with Keycloak. The Keycloak will respond with a Keycloak token. The service will exchange that token with Keycloak and then to Google, and Google will return with a Google token. That Google token will contain the permission on what Google APIs can be accessed by the user. Keycloak will return that Google token, and finally, our service will use that Google token to access the calendar API available within Google. In this section, we will take a look at Google Cloud Console. If you haven't done so, you can register an account at cloud.google.com/cloud console. I already created my account some time ago, so I'll just use this for the demonstration. And also, you may want to visit developers.google.com/APIs-Explorer. This page contains all the APIs provided by Google, such as calendar and email, which we will use in our project later. Inside Google Console, we need to configure the OAuth2 client credential and the OAuth consent screen. Now let's go back to Google Cloud Console. Hit the navigation menu, and under APIs and services, we have the credentials and the OAuth consent screen. Let's take a look at credentials first. Here we need to create a new credentials of type OAuth client ID. Set web application as the type and enter the name that you want. Here we have the authorized JavaScript origins. This is where the request will be coming from. Normally, this is your front-end or client application. The URL of that application and the authorized redirect URIs. This is where Google will redirect after successful login. Now you need to set them, especially in production environment. I already created my client, so I will just share the values that I used. For the authorized JavaScript origins, I'm normally running in React. So that's why I have localhost for 8080. That is my client application. And for the authorized redirect URIs, I have localhost 3000 post sign in. And I have other common authorized URIs here. So this one is for Amazon Cognito. This one is for Postman. This one is for Google. This one is for Keycloak. And at the right side, we have the client ID and the client secret. We need to save these values because we will use them later in our Spring Boot application. Next would be the OAuth consent screen. Again, go back to APIs and services and hit the OAuth consent screen. This is your page for all the client credentials, or basically for this lab project. So I already configured mine. So let's try to edit this so that you can see the values that I've used. This is the Here we have the authorized domains. This is where my application would be running, and this is the email address of the developer. Now let's save and continue. Here we have the scopes. So basically these are the permissions that we are giving to the user associated with this project. So we give them the permission to access the email, profile, and OpenID. In the next screen, we specified the email address that we will be able to use this project. So for this test, we are using my email, which is CZETSUYA@gmail.com. Now hit save, and you should be able to save your OAuth consent screen. The next step for this video is to configure our Keycloak server. We will create a client, save the secret, and download the JSON configuration file. We will configure the Google Identity Provider and token exchange permission. Before we begin, make sure to check the description of this video and download or check out the project that I've shared, which we will use for testing later. This is the project that I created for testing. Here we have a Docker folder that contains a Docker file. So this is a custom Keycloak instance, and I also created a Docker compose which will run that instance of Keycloak and a MySQL server. Now let's run our custom Keycloak instance. We should be able to access it in localhost port 8080, and the default username and password is keycloak.admin. Here I already created my realm, but if you haven't done so, obviously you haven't, because if this is your first time running that Keycloak instance, then you should only have the master realm here. Just click the realm and enter the realm name that you want. Here I have my CZETSUYATECH realm. Now under it you have clients, click it, and here we will create our client. I'll be using Webfront as the name. Click next. In the next screen, enable the client authentication and the authorization checkbox, because we will need a client password for our testing later. Click next, and here we have some inputs that we need to provide. So the valid redirects, it's where Keycloak will redirect after a successful login. We have origins, is the origin of the client request. So you need to provide a valid URLs once you're in production. Click save. Now we need to get our client password. So under the credentials tab, here you can copy this value. So you can paste it in a notepad so that you can easily access it later. And finally, we need to download the configuration. Download the JSON configuration file. Here we are copying it. Our realm is CZETSUYATECH realm. This is the server URL, localhost port 8080, and our resource or client is Webfront. We need this because we will paste it in our project. So in our project, which is Auth Exchange Token, go inside the folder source main resources, and there is a keycloak.json file. You need to paste it there, or you can just copy and paste the secret. This is our application.yml file. We also need to paste the client secret here. So under security OO2 client registration, we are registering Keycloak, and here we have the client ID Webfront and the client secret, which is this value. Next, we will need to configure the Google Identity Provider. Identity providers are third-party services that allow users to log into Keycloak. In our example, we will do an authorization as well by exchanging the Keycloak token to Google to allow us to call Google API services such as Calendar and Gmail. So log in to Keycloak using the admin user. click the Identity Providers tab and find Google. Here it will ask for our client ID and client secret. Remember the client ID and secret that we have in Google, so you need to put them here. I will put them here later. For now, I will just randomly put an ID and click Add. In the advanced settings, make sure to put the following scopes: the email, profile, open ID, and this one is for accessing the calendars as well as Gmail. Now, if you need more scopes, you can go to the Google API's URL that I've sent or I shared earlier. For example, if you wanted to access the maps or any other Google services, so you can go there. You can choose to store the token as well, but for now this should be enough. Hit save. So now that we have our identity provider, it's now time to configure the permission. So go to the permission tab and enable the permissions. Here we have the exchange token. Open it, and in the authorization scopes, select the token exchange if it's not selected yet, and choose unanimous. Click save. Later we need to go back here. So after that, we need to click the client details at the top corner. It will redirect us to the authorization tab, and under the authorization tab, we need to click the policies. Here we need to create a new policy and select the client, give its name, maybe Google Token Exchange. Our client would be our web front. The logic is positive. Click save. Now we need to go back to our identity provider, Google, and in the permission, click the token exchange, and here we should have a new policy, Google Token Exchange. Select that and click save. Now the setup is complete and we are ready to test token exchange. We will be doing that by using Postman. It's finally time to start our testing, and we will begin by testing the configuration of our Keycloak instance. We can do that by using Postman. So if you haven't done so, download Postman. Now in our Keycloak instance, I renamed the realm to CZETSUYATECH so that it's easier. And we need to check our configuration. Make sure that your web front credentials has a valid client secret. So it should not be asterisk even if you click the I button. If it's all asterisk, just click the regenerate button, copy the client secret again. And also one common this place is normally cause a problem within Keycloak. Inside Google, you have the client secret, and sometimes when you copy the wrong value, it might cause some errors that is hard to debug. So just make sure that you copy the correct client secret from Google. And with that, we can proceed with the testing. Now let's go back to Postman. Here I'm posting to this Keycloak URL. Realm CZETSUYATECH protocol OpenID token, because I need to get a token and I need to exchange that token to Google. So to be able to authorize my request, I have configured Postman to get a token. So this is that configuration. In the callback URL, we have getpostman.com O2 callback. Auth URL is realms CZETSUYATECH protocol OpenID connect. Auth the same with the access token URL. But the difference is that this one is auth This one is token. For the client ID and the client secret, these are the values that we have saved earlier. So I use an environment variable for that. This is the client ID and the client secret. Scope is profile, open ID, and email. So now we can send or get a new access token from Keycloak. So proceed, because I'm already logged in. But if you're not logged in yet, it will redirect to a Google page and it will ask you to log in. So in this case, I'm using CZETSUYA@gmail.com, and it will show the permissions that we have specified in Google: the profile, email, open ID, calendars, and messages. So this is our access token. We need to copy it, or maybe we can just use the token. What it will do is it will set the token for this particular request to that newly generated one. But in case we wanted to use it in our other requests, we can paste it in the bearer token in the environment variable of Postman. So now we are ready to exchange this token with Google. Now click save, and in the response we have this access token. Now this is coming from Google. We can now use this to request or to call Google APIs such as calendar and messages, which we will do later after we created and start our Spring Boot project. At this point, you should already check out the project that I shared in the description box of this video. It should look like this. Again, we have the Docker container here, and at this point you should be running this Keycloak instance. Let's create a new run configuration inside IntelliJ IDE. You can use any other IDE like Eclipse, but I prefer IntelliJ. They have a community version that you can use. So at the right side or in the menu, you should be able to see run configuration. So I already created mine. It's just a simple Spring Boot run configuration, and I have my main class as application. Before you run the class or before you run the application, make sure that you have changed the value of the Keycloak client secret, and you have downloaded and pasted the keycloak.json file from Keycloak. So I already explained this earlier. Everything is configured aside from those two places. Now if you don't want to run, or if you don't want to configure Keycloak, I provided a already configured realm which you can export inside Keycloak. So it's inside docs and Keycloak. Now let's run our Spring Boot application, and let's make sure that our Keycloak instance is still running and running without any error. As we can see in the terminal of IntelliJ, it's still running. And now let's take a look at the Spring Boot application that we have just run. It's running on port 8081, so we should be able to access our server there. Localhost port 8081, and it should ask us to log in. Remember, we don't have any user defined inside Keycloak. Instead, we will be using external users, in this particular case from Google. So it should ask us to log in. I already provided my password for user CZETSUYA@gmail.com, and I already accepted the permission, messages, calendars, profile, open ID. That's why it didn't ask me this time. So the first thing that you should do is save the token. It will save so what it will do is get the Keycloak token, exchange it with a Google token from Google, and save it in the database. Now that it's saved, we can now call Google APIs such as calendar and email. That is useful if you don't want to exchange token every time you call a Google API. So just provide a refresh functionality so that it will get a new Google token, or perhaps a timer that expires and triggers a refresh. So let's try to access our Google Calendar entries. So as we can see here, we can see all the calendars related to CZETSUYA@gmail.com. We can also drill with the content. For example, this is CZETSUYA@gmail.com, so it will so these are all the calendars for my account. If I enter CZETSUYA@gmail.com, these are all the events associated with that calendar. Okay, and for the other API, so this is the email. I'm not sure what it is. Let's see. Oh, okay. So here we can see that this message ID has this message from Google, or from Google Messages. Now let's see the other message. Well, it's slow sometimes. Pretty slow. Okay, nothing private here, so I'm just sharing it to you. So this was the message from Google when I permitted the access to my account. So you should receive something like this. So here, as we can see, we have successfully accessed the calendar, or we have successfully called both the calendar and email API from Google using a Keycloak token. Next, we will take a look at our code and explain how this works. In this final leg of this video, we will break down our project and try to understand how a token exchange between Keycloak and Google within the Java code. So once again, this is our project. We have our Docker configurations here. This is our main source folder, and we have the resources where our application configuration file is. So this is the Spring Boot configuration, basically, so it connects to the database, and this is the security configuration, which connects to our Keycloak instance. This is our Keycloak configuration that is used by Keycloak to load or to initialize its configuration properly. These are the templates powered by TinyLeap. So these are the views or the pages that you have seen in the browser. So here we have the list of calendars as well as messages and the detail page. So if you're not familiar with TinyLeap, it's very easy to understand. So you have your tags here that you can use to access the beans or the controllers from the Java code, which I will show later. So these are the Java classes that we have. Basically, we have MVCs, or this is our controllers, the services, and the persistence layer. The persistence layer simply saves the token into the database. So let's take a look at our controllers. Basically, it maps to the views that we have. For example, the calendar. We have here the calendar entries, which lists the calendars that we have for the account that we have logged in. So first, as we can see, they have the refresh token call. What it will do is it will check if we already have a token saved for that particular user in the database. Otherwise, it will call the refresh token, meaning it will initialize and save that token. And then it will load the view. So it will call the calendar, and it will render the page with the calendar entries. So let's take a look how that happens. Inside this call, the get calendars, which is basically the same in the calendar event detail. What happens is that it initializes the calendar client like this. So to be able to access this library, or I mean these libraries are already provided by these libraries are already provided by Google. As we can see here, these are the dependencies for our project. We have the Spring Boot security, and what's important is the Keycloak OATS client, which we use to communicate with Keycloak, and the Google API dependencies. So this is for client for communication, the services for calendar, Gmail, and parsing the response using Jackson. So going back to our code, here we're trying to initialize our current calendar client. So we get the token from the access token. So this is simply a wrapper that we inject here. Again, this access token comes from here. So when we call the view, it refreshes the token, it gets a new Keycloak token, and it saves it in the token wrapper. And that is the value for this bean access token, and we get the token. This is the Google token. So let's see how it works. So we have provided here the Keycloak token, and it's calling the get token exchanger from our service class and call the exchange token. So this is a request going to Keycloak. So this is what we're doing in Postman earlier. The exchange token. Here, we are calling this URL. But instead of doing it in Postman, now we're doing it via code. And as we can see, this is the token endpoint, which is basically this URL. And in the request body, we have these parameters. So the client ID, secret, grant type, requested token type. So they are basically the same. It will send a request to Keycloak, and we will get a response. That response will have a token. Now this is the Google token that we will use to call the Google Calendar. So here, okay, calendar entries, calendar client. So this class is coming from the Google API client. So we set the access token to the Google token, and now it's properly initialized. We are building a new instance of the calendar API. So that's why here we are calling the calendar list, which returns the list of calendar associated to that user. And as I mentioned, it's the same. So this is the calendar, this is the calendar events. The sequence of configuration calls, it's the same. So calendar client, this is calendar list, this is events. So now we're getting the list of events for this particular calendar ID, and we're just getting the maximum of 10 results. So this is the calendar event detail, events get calendar with this event ID. So that's what happens here, which is basically the same with what happens inside the Gmail service. Here we have a Gmail client, which is basically the same as the calendar client that we have earlier. So we're using the Keycloak token, exchange it with a Google token, and initialize a new Google credential. We will use that credential to initialize a Gmail API instance that we will use, or that we can use to get the users messages, so list for this particular account, and we can get the message using a particular ID.
Thanks for joining me in this brief demo. If you have any question, you can ask in the comment section of this video. Once again, this is Ed. Happy coding!